So, hello, Nikolay.
Hello.
Yeah, it is a pleasure for us to having you on our virtual stage.
Thank you.
I'm currently activating your presentation.
Okay.
So yeah, this is using blockchain to protect data from biometric systems for analysis and access control. So the
Yes.
stage is yours. Over to you. Thank you.
Thank you. Thank you. Well, thank you, Sergey. Good day, everyone. Our topic of our research, me and my colleagues from Information Technology Department, is using blockchain to protect data from biometric systems for analysis and access control. Well, it's actually an applied decision, software plus blockchain technologies. So, well, a little bit about us. It's National University at the Odessa Polytechnics. We are presented 126 fields of IT, and we are also an organizers of each year scientific practical conference, which topic of research are actually considered and connected with our today's topic. It's IT, data analysis, and software engineering. So, problem relevance. First of all, we need to say that today's a very important task for today is pattern recognition in images, which were previously considered technically uh, due to a number of different uh, difficulties and various reasons when we're talking about the security. In particular, processes of detecting anomalous phenomena on images or subjects located, wanted, or posing a threat to society or business, and are relevant in the field of security and ensuring access of individuals to close the limits objects. For example, and it's a subject of our researches, is an access control systems. Also, these systems can be provided in local problems and in enterprise. And we discuss our problem in a context or risk-based approach to preventively informing security services about possible risks or damages caused by things when important data is might be hacking by some other people. And we also need to clear that among the science used in practice in different papers or softwares, recognition of individual subjects, actually faces, is carried out, and there are different problems and different ways to make recognition worse. For example, it's close speed of movement if we're talking about video cameras, anthropometric kind of different features, and not all of the existing systems that we can see in open access are open and effectively for supporting biometrical personal data recognition. So the urgent task is develop an application, concepts, methods, and of course in the software, which can implement relevant methods for recognizing biometrical data, as well as many as a means for ensuring the protection of information of access security systems capable of accounting for various sets of features. And of course, it's really important to make sure that all these tasks are calculated and works in online. So we can say when we're talking about access control systems operating different difficulties. So we can say that the first difficulty is large values of stored and regularly updated information. databases for recognition results, credential of people and persons with different access rights to the system, and so on, logs. Second one is centralized solution architecture, which makes it difficult to scale data protection and replication mechanisms, thereby reducing the overall reliability of such systems. So one more problem is high risks of gaining unauthorized access for commercially available data. And the last one, of course, is data leaks. So we discovered and we decided to use some recognition concepts and build it in one whole system and maybe even a hybrid method, which consists angle faces, algorithms and methods, local binary patterns, and we can improve it in our research with deep neural networks convolutional architecture. On this slide, we can see some formula about angle faces approach. The way we can calculate the basic components of image to discover it on a picture or even on a video flow if we discrete this video flow by the pictures. And the second one concept, it's a local binary pattern algorithm. We can see also on this slide some formula that mathematically describes this algorithm in a few steps to calculate and make it clear and have additional features by brightness values of pixels of picture and to find the area in a picture which we need to analyze actually a face. And the whole concept schematic of our approach is shown in this slide, and we can see that results of angle face model comes to a LBP model, local binary patterns, and also the next step is to get this data on input of deep neural network model. Well, what about the blockchain? We discovered that the problem of our system is actually the cybersecurity problem, because the main field of our research is data science, data mining, and machine learning. But we need to provide high level of security data of all these video streams or pictures that we can collect while our system is working. So the generated chain model is based of blockchain by the Ethereum architecture, and it's private due to a number of disadvantages specific to the proof of work algorithm in our case, in particular due to restrictions imposed by its security part. So some modifications of this approach is proposed by one of our co-authors of our state, and we use the ECDSA algorithm to achieve the greater degree of performance when processing protection multimedia data of high permissions. Actually, I didn't say that the volume of data is kind of big because system can work online a lot of days, and people who are working with the system, they generate a lot of faces, a lot of data. So the second one, the essence of blockchain application process can be described as follows. The generated images are placed in a private decentralized data registry. Each uploaded file, image, log, metadata, and so on is hashed, and as a resulting unique fingerprint of this file is entered into a blockchain. The recording contains timestamps, which includes the possibility of making changes. No, we all know it's, I guess, we all good know this. The recording contains, it's necessary to verify the authenticity of record, a rehash operation we need to perform. And the received IPFS hash is compared with the other one, which is stored in the blockchain. And for the purpose of additional protection, we use the Juno protocol, but actually Juno protocol is used now only in the project, but it's not implemented as a different module in the system. But it can be done in the future, and it can improve the security functions of the blockchain, protecting against accidental hacker attacks. But we did not test this feature for that moment. A couple of pictures of our system. That's a use case diagram. In short way, we can upload in our system prototype. It's actually a Python Django software for this moment. We can add persons to database to our work space, update information about persons, and start recognition and train our models and choose algorithms. This slide shows us a class diagram fragment. Actually, there's a lot of program classes, but here we can see some of classes that consist of model of our one of the model of our system and its connections to the base model on the Django framework. A little bit database fragment we can see we actually have a SQL database and NoSQL database. SQL database for structuring some metadata and some test data, and NoSQL is Mongo DB we used to perform structuring data with different cameras, different input devices to have a big heap of data. We can analyze it with our different models for different things. The system deployment diagram for actually not for industrial, but or actually for test use, because our system is now as a prototype. We can see on this slide, we can use MySQL, as I said, as a SQL database, and some components as integrates programs, control staff programs, and interface programs. Actually, it's different packages of modules. And system performance, we need to discover and to research the ways our system works. And we use three modes of operation without data protection at all. With Hrua implementation, it's kind of old, but actually workful way to build a security system for images, and with blockchain implementation. The whole implementation, as I said, based on Django framework, Python, some of libraries for data science and machine learning, as we can see on this slide. And we also used HTRR metric, half on a total error, which led us to calculate the mean quality of our system works. So we make a couple of experiments for that moment. We used some central processor. We used couple of cameras to collect data and simulate the operation mode with 16 cameras. We used about 6 hours of work day in office of workers. Or actually, our co-authors help us with this data. And during this period, about 800 faces per hour was detected. We also use ready data sets like a Flisk face, male and female faces, and YouTube faces to aggregate more powerful data set to train our deep neural network on this data to study, to learn our model, to make it more representative and more discrete in a sense of quality. And we actually have such a result performance. We can see that CPU use with blockchain is kind of a little bit lower than in Hrua, because Hrua is not so effective in memory operations. And no security, of course, it was faster, but we can see that it's not the way they use such systems as we can develop for access, because it's not the best way to do. And blockchain shows great results for us. We can say in the conclusion that, as we can see, the last mode, like I said, implements blockchain is characterized by a slight decrease of recognition accuracy, but it's not so big decreasing, and the system performance remains in the level of other less resource intensive modes. And I would like to say that studies of the development concept within the framework of creating software prototype of our system showed its adequacy and expendency of use of the practical tasks in the future. The stability of blockchain enabled system that we used in this our approach, um, the high scalability of level security led us to state that in the future we can make this system more stainless and um, um, deploy this system a larger number of nodes and make it in a microservice architecture. And as a last conclusions, we can say that our system prototype can be flexibly supplemented with new functionality due to the modularity of its structure, because we also are working right now with new modules functional. In its areas of application can be not only for biometric identification for ACS, but with different tasks to create systems that can store security information, not only images, but images at the first stage, of course. And further ways to develop the projects are adaptation and addition of our data protection approaches along with the blockchain, addition and development of the created prototype with larger number of algorithms, not only with two of our angle faces and local binary patterns, cleaning and processing data, elimination artifacts and profiling methods in order to study and compare the features of the work of different configurations of objects, and work with the pictures, with the images, and with video streams, video flows that have a bad quality. And thank you for your attention. If you got any questions, I would like to answer it. Thank you.
Yeah, so thank you so much for this paper. It actually it looks that you are very much prepared and you are far in developing the proofs. Maybe it was in the paper. Maybe I just missed it. It is already 6 hour end of the 6 hour of the presentation. So can you please tell me, you did try it with the real data, right? So there was some real data tests where you got some accumulated data, and this worked for you, right? Can you
Yes.
elaborate this part a little bit?
I actually didn't present it here because it's a part of a different state, which we are now print in a different conference. So I can show it for that moment. But shortly, I can say that we actually collect real data and used also ready data to no, to make better data set. And we also discovered the quality and the metrics not only with this, like I said, with the blockchain, but without blockchain, just the models, how it works, and we measure accuracy, function loss for a natural network. For example, we were discovered different hyperparameters for deep learning, deep neural network. Used a grid search method to find the optimal values for our models of natural networks. It's about 10 or 11 experiments we did Each experiment in time was about 2 or 3 days, because as it's a lot of data, we need to process to make our to create our models. And we showed that using our methods, I mean, like I said in the first part of our presentation, when we combined angle faces, LBM, and deep natural network, without deep natural network, only with two methods, the accuracy was about 60%. But when we combined all these in a hybrid system, we showed the accuracy about of image recognition about 89, 92%. I mean, it's about plus 30, 25, 30%. It's our experimental results. We can show it, like I said, in different papers in a different conference. And it was the first step of our research. And the second step is that we are doing now is to provide blockchain actually in our system to protect it, because our work is more as a research and development, but not really close to security. So we decided to combine these things and combine this great thing blockchain to make it possible to make it the level of our security in our system is more higher.
Well, thank you so much. That's a very good answer. Let's check if anyone has other questions. And if not, we are processing to the next paper presentation, which will be the final one for the final paper presentation today. And then we will go back to the keynotes format. Um, well, I don't see other questions. So then, yeah, thank you so much for being with us. I am starting the. I'm starting the. Inviting the new speaker to the stage. Nicholas, thanks for the good presentation. Thank you.
Thank you, Sergey. Thank you, everybody. Good day.
Yeah. Have a good day. Thank you.